So really excited to be here today. I gave basically the same demo at a meetup we held at Adobe last week, and half of it just completely did not work because I had made some code changes without testing it beforehand, but it's all up and running right now, so it's gonna all work, right? So who here has used SaltStack before at all? So some of you are kind of brand new. Okay. So I'll do a little bit, I'm going to talk a little bit about what Salt is, a little bit about its architecture. I'll assume some basic knowledge of config management and system administration, that type of thing. This class will be about some advanced use cases of Salt reactors, Salt's event API, beacons, things like that, which are some pretty new features that we've come out with. So now I like to do lots of hands-on live coding and stuff. So if we're into a bug, you'll get to see me troubleshoot stuff, but I think it's all pretty good to go. This is my only slide, so you don't have to worry about me reading off a bunch of boring slides today. So, okay. So to begin with, let me, so I'm logged into a SaltMaster that I have running on Rackspace. And just to kind of make sure we kind of have a baseline understanding of how Salt works. So SaltMaster is like your central controlling server, runs everything. And the very typical general use case is you have a SaltMaster and you have a number of servers that you are controlling with your SaltMaster. There's a little agent that runs on your server. We call the Salt minion. So usually we'll hear say, you have your SaltMaster and all your minions that are controlled by your master. Let me turn down the light. Is that font good there? Yes. Okay. So we have a Salt minion or SaltMaster, and I'm running a minion on the SaltMaster itself as well. So if I come here, I can run a Salt command. So what this command is going to do is first we invoke Salt. The second thing there is a target. And so the asterisk is our wildcard. So we're going to send a command on all of our servers we have connected. There's some good seats up here in the front if you'd like to come sit down. And then we have a Salt module called test, and then ping is a function within that module. If you're familiar with Python at all, it is literally just a normal Python module. If you go into the Salt code base, which I've checked out right here, if we open up Salt modules test.py, you can see thank you, ping. So here we have function ping. We have some documentation about the code, and then essentially this returns true. Here's test.sleep. You can pass it an integer, and it'll sleep for however many seconds you specify, and then it just returns true. So again, this is just straightforward Python. Nothing much to do there. And so this is just going to tell my servers to return the value true. There are some other ones like test.echo. They'll just return whatever you type in. And then there's a whole library, Hypercharger. There's a whole library of modules that do everything under the sun, from configuring your network interfaces, installing software, managing databases, a whole variety of things that just come out of the box built for Salt. A lot of them are cross-platform. So if you do package.install vim, for example, that'll work on OpenBSD, Windows, Red Hat, Solaris, just out of the box across all of those. So that's really handy there. So those are some of the modules and functions you can do there. There's a thing called Salt State, where instead of doing these on-the-fly commands, in fact, let's pull some information here. Here's the output of the disk usage on my server. let's list all the software that we have installed on this server here. Just have to wait for apt to respond there. There's all our software. Oh, you know what? I want that in JSON, so I can import that into another application and use that data. There it is, all in JSON. So this is all stuff you can run on the fly across your infrastructure. So when I first got involved with Salt, this is mostly what we had. Salt states hadn't really been finalized yet. They were still kind of the beta stage about three and a half years ago. And Salt basically was this remote execution system where you could run all these commands across thousands of servers immediately. So instead of having to like check into a database and see, okay, what software should be installed on this server or this cluster of servers, you could just go out and ask it right now, what's installed. You don't have to, depend on your sysadmins being obedient and keeping track of every change they make to the systems. You just require the system as right now. Right now, so Salt is useful if you're using Vagrant. I use Salt all the time with Vagrant, with 1 or 5 VMs on a laptop when I'm testing stuff. It's useful for a 1 server, 2 server Django deployments, and it's useful for LinkedIn when they're running 22,000 servers off one Salt master. It scales from your Raspberry Pi to the biggest infrastructures out there. In fact, there's even bigger infrastructures. Some of our enterprise customers that are even larger than that are managed by Salt. And that was the thing that really drew me in was, this powerful cross-platform control over all your servers. I had to deal with deploying code, deploying configuration changes, documentation changes, all kinds of things like that across disparate data centers and offices and things. And Salt just made it a dream to just do some updates, push them out, and then get confirmation that they're there. So that's the very kind of basic layout. Your Salt master, you have your minions. Now Salt's very flexible. It's designed to be pluggable and flexible. So we try, one of the philosophies behind the development of Salt is we try not to force you into any one way of thinking. So if we have people that use the Salt minion just by itself with no Salt master, and they pull their configs from Git or from S3 from other locations, and they run things on a timer. We have people that use Salt SSH, so that allows you to not have a constant connection to all your minions, but when you want to run a command, it'll connect through SSH to run the commands on them. It's just extremely flexible. So if you use Salt, you're not going to be forced to change how all your infrastructure works. So a lot of people will come in and want to use Salt because I want to manage some Docker stuff and I want to manage some new stuff we're building out. But then they realize all their legacy stuff that's not going away for another 10, 20 years, you can still use Salt to integrate all your legacy stuff and all your new hotness and everywhere in between. So one of our customers I spent some time at, they were doing all kinds of really awesome Node.js stuff on their website and pulling maybe all the really new kind of cutting edge stuff for their actual website. But they had a Cold Fusion server that they had kind of forced this REST API on top of, and they're like, oh, we got to manage this Cold Fusion thing. And so I spent a few days building out some Salt states to manage their Cold Fusion as well. So they, Salt can allow you to manage all that stuff. So in this example here, we have one Salt master and a minion, and so generally you have your Salt states. So you say, I want my server to look like this, and you can tell it on a one-off command. Okay, make sure all your configs and your packages look like this. Now, because we have this really fast connection between the master and minion, which is encrypted, it's secure, it's and very, very fast, that allows us to have this rich flow of data, not just from the master to the minion, but back and forth. So there's a lot of things you can do with that. So the first thing we did was we had what's called the event bus. The event bus, if you watch the event bus, various things happen when you do things on your system. And so Salt uses this event bus internally, and you can watch that. So we have a nice little runner here that will allow us to So this is a runner. A runner is not as a script or a small application that runs on the SaltMaster itself. So state.event, pretty equals true. This will allow us to see different events that are happening on the system. So it's going to output these here. So there's nothing happening right now. In this other screen, I'm going to restart my minion service. Okay, so I restarted the minion service, and you can see here we had some auth events that came through. This is the public key of the minion, various things like that. Down here we have, this is the one I was caring about, is the start tag. So each event has a tag. So here this one's salt, minion, Boucha. Boucha is my last name. It's also the name of this server. And start. So this is just saying on the SaltMaster that this event happens, this tag. Now, the section below that is the data portion. We have this timestamp. We have, this is a minion event. We have some text saying, hey, minion Boucha started Friday at 8:17 a.m. The time zone is different on the server there. It has the ID and some other information there. And again, this is a data structure that you can look at. Now, all kinds of things, like I said, will happen, auth events. If I had more minions, you see occasional auth key regenerations that'll come through and that type of thing. You can also send your own custom events. So you can send these on the command line. So if I'm up here on the minion, tell you what, I'm going to go over here a little bit so I can see better. There's a function called event.firemaster. Then you pass in, I think it's data first. Again, this could be any kind of data structure. It could be just text. It could be, like a JSON dictionary, list, all that kind of stuff. And then we have a tag you want to use. So I can run an event, and then you can see over here, towards the top, you can see Dave my tag. That's the tag that I specified. And then the data is stuff. It's just a string that I put there. So you can do this on the command line. You can have your own application send an event. So I've worked with customers that have like a Jenkins set up, and if tests pass on a build, then they'll send an event to the SaltMaster saying, hey, this build with this git SHA is good, and then the SaltMaster will do something to talk about. So you can send your own custom events, and again, it can be, like I said, any application that you want. You can import, there's a Python library, you can import Salt and send events. You can shell out and call something like that. There's various ways to send those events.
You guys out that to syslog at all?
Yes. Wait, no, the events are ephemeral. So you can log them. We actually, so the very next thing we'll show is what we call the reactor. So you can do various things with that. We'll get to that in a moment. The events are ephemeral. They're not saved by default. But they do go over the encrypted 0MQ connection there. So, what's that?
By changing the Etsy minion and master configuration, correct?
So, so the question was, or the statement was, you can log those. Yeah. So. The events don't get logged in the main SaltMaster minion logs because this is a ton of data, and it actually doesn't refer directly to the performance or logging of the application itself. So, by default, these will not show up in your logs because they're not things that your minion's doing or your master is doing. These are events flowing through. We do have people that'll stick them in a database and that type of thing, but you have to prune that regularly because it can get pretty huge pretty quickly. Okay, so this is the first step. We have our communication bus. We have the ability to send events about things that are happening. So what can we do with that? So another example we have is we had a customer that's had it's a game servers, right? So they'd have so many application servers that hosted kind of like a world, and once that server reached a certain level of capacity, like network connection or gamer connections, they would send a custom event to the Salt event bus to the Salt master saying, "Hey, I've reached 500 connections. Don't send any more to me," and that's all it needed to do. It would send that up. When these events come up, then we have what we call a reactor on the Salt master. Actually, in the newer versions, the developed version of Salt, there's actually a reactor on the minion as well. But on the master, there's a reactor that sits there and scans these tags. So, like Dave, my tag on that custom one that I did, or this return here down below, and this reactor allows you to do things based on that. So, let's say when that Dave, my tag got sent, I want to say, oh, okay, I got stuff in that data, so I'm going to update a web page with stuff. So then the Salt master can go do something that you want. So for example, in that gaming example, when a message came through saying that the server had reached capacity, then the master would update some config so that server would not get any new connections, and it would spin up some other VMs. I think they would do actually 5 more at a time when that would happen, and then add those into this kind of quasi cluster that they had, so they could dynamically scale as these connections came in. And they would also do the same thing as they would reach a lower level bound. I think it was like 20 or something like that. When it hit 20, it would send that message, and then the reactor would then say, "Oh, okay, we've got several servers now that are down to 20%. It would consolidate, move some of those users from those connections, and then drop some of those VMs that were running those worlds or whatever it was." So what's nice about that is that kind of separates, gives you a separation of concerns. The thing sending the event, a piece of your application, could be a big red button sitting on your boss's desk, whatever that is. It doesn't have to know what's going to happen when it sends that event. It just knows that, hey, I need to do this thing. And then on your Salt master, you can do something with that. So and then the config for that is pretty straightforward. So here we have in our master config, we have this reactor section. And here I'm looking for a Jenkins tag, it's Technicolor tag. You can see here I have an asterisk. That means I don't care what was in this section of the tag. I'm going to accept it anyways. So for example, here this would be, a minion name would be here normally. So the tag would look like that, but I don't care what the minion is. Whenever we see anything with that tag, we're going to catch that. And when it sees a tag that matches these, then it's going to execute this Salt reactor. And that's just I'm not going to get into that because that's kind of a whole different deep subject, but essentially those are a set of Salt modules and states and things that do whatever tasks you want to have done. So can you see some of the power there of ability to have build out self-healing infrastructure, build out self-monitoring, monitoring, healing, things there. Really, the sky's the limit on what you want to do. I did build a system of queues for this as well. So we had a customer, for example, that would have they had a system to re-image bare metal hardware, and it was a pretty simple. They had a command they would run, and they would give it a list of servers, and then what class of server those should be when they were done, and it would go out and reclassify them. So they would oversubscribe their database clusters, oversubscribe their application clusters and that type of thing. And if one of them, started getting full, they would take some of the oversubscribed, application servers and then repurpose them for the database cluster, things like that. And so they're using the reactor for that. Now, the problem they were concerned about is, the reactor does everything immediately. And so they were kind of concerned that something would go haywire and it would start getting all these messages that, hey, take all these servers and re-image them and push them over here. And it also was actually more resource efficient to do like 5 at a time or 10 at a time. And so we added a queuing system so that you could, when these events come through, stick them in a queue, and then you could process that queue on a whatever time frame you want. So once an hour, every 5 minutes, whatever makes sense, and you can process those queues as needed, as makes sense. You can also monitor those queues. So like they had a bunch of dashboards, and they could see those queues. So if there were 5 items in the queue, or 10 or 20 items in the queue, that's great. But if something they had like 40,000 items in the queue, stop that. We don't want to like destroy the infrastructure automatically, because these automation tools can automate you, out of business, right? So having like a relief valve there to make sure things were in a proper location is very useful. Now, to make some of this a little simpler, we recently added a thing called a beacon. And a beacon is a subsystem on the Salt Minion that checks for something and then sends an event when that thing happens. By default, they get processed once a second. You can also set an interval to decide when those are. So we have several different types of beacons.
So you said it gets processed once per second. Does that mean it runs the check once per second, or it only sends the event once per second?
It runs the check once per second, by default. And you can set. And I'll show some examples. You could change that interval for what you want.
I'm sorry to keep
No,
going on.
actually, I love questions. So please feel free to interrupt.
Is there any was that just an arbitrary 1 second? Let's choose 1 second, or was there a specific reason?
So the Salt Minion has a kind of garbage collection thing that happens once a second. So it has like a loop that it does once a second. And so the beacon is part of that process.
So to say, I probably don't need to check my configuration files once per second, but
Yeah, totally.
So I'm just curious why that was the reasoning.
Yeah, that's totally the reason. And you can set that interval. So if you want it to be, 600 seconds or something or whatever.
Every 5 minutes check this or whatever.
Yeah, exactly. Definitely.
What's the advantage in using the Salt Reactor system as opposed to running a cron job that checks your Apache services up and running and just kick it if it's down?
So the question was, what's the benefit of using the reactor and beacons or something like that, as opposed to just running a state or high state every so often with cron?
Your own cron job is checking an Apache.
Well, so that's totally, people do that, and that's totally a valid way. Running a cron job to do things is a totally valid way to run some of those things. It kind of depends on your goals with that process and your goals, your existing way of working. So if you do a lot of things with crons and you have a lot of ways to update and manage that list of cron jobs that are running, that type of thing, that totally makes sense. And that will run every hour, 30 minutes, or whatever you want that to be. But if that's like a one-off that you don't manage all those and things, my experience has been that those kind of things get forgotten. And then you have this cron job running this thing that people forget about. And then you get undesired behavior later on when you're trying to do something, and this thing keeps poking you from somewhere. Like, what is going on here? So if it's a one-off, I'd say don't do that. If it's something, like I said, you have a lot of existing infrastructure doing that, I think that makes a lot of sense. The benefits of using the reactor and beacons and that type of thing, is that it's more reactive to actually what's happening on your system. So I don't know that I would necessarily use beacons or the reactor to check for a process that's running. Let me show you what beacons do here for a second, and then I think I'll kind of answer a little bit what you do here. So some examples of some of the beacons we have. We have a disk usage beacon, an iNotify beacon, journal D beacon, system load beacon. Well, some of these are new. Network info beacon, and we have a service beacon. I didn't know that one. We have a Twilio beacon, which I'll show you in a minute. That's kind of weird, right? WTMP is a subsystem that allows you to see who's logged in, who's logging in. So what you can do with some of these things is so the WTMP allows you to say, oh, who's logged in the system. So for an example, say you have some production servers that nobody's supposed to log into, and one of your Django developers logs into that system. An event will be sent up to your Salt master saying, Sam Beveridge is logged into your Django server. He should not be doing that because he should be configuring everything through his Salt states. Now on the reactor, then you do something. So, okay, this user logged in, what do I do? Maybe there's a whitelist of some people that are allowed to. Maybe there's a whitelist of people during certain time frames where they're allowed to. And if they're not, log them out. Or maybe send a message that someone logged into this production server. For example, the iNotify, let's do that. The iNotify allows us to watch a file or a directory structure and then do something when a file changes in there. So let's look and see what that looks like here. So I have some examples already commented out. So we're going to watch this file, and we're also going to watch this directory here. There's also some options. There's various options you can do. And then you can also set an interval. I'm not going to comment that out. So by default, this is going to happen once a second, and but we're going to just do that. Do that right there. Let's restart my minion service. Okay, so we see the events passing through over here. We authenticated with our all the encryption, and then we have a tag that the minion started. So let's go into that directory. Okay, so there's our blah.txt. So I'm just going to echo into blah.txt. And then we'll see, boom, we got notified that that text file is being modified, and that we got two of them there. So anyway, I think that there's two. If you look at the actual system level things that are happening, that's why we got two different texts, because there are different notifications. So if I do like ls testing, you can see here just scanning that directory gives us two different tags that are opening and ISDR that are happening down below. Let's make another file. See here, we got another event telling us that the file was opened and written, and with the close right. And did it? Oh, I think I'm not watching for that because I had those custom events. I'm not watching all the events, so I think that didn't happen there. So So a demo that I gave out in Belgium, when this first came out, like Tom had finished writing this feature on the plane to Belgium when we were going to give this talk. And I had it set up so I was watching a subdirectory of my Etsy directory there. And I had a salt state that laid down some config files that I wanted. And I had it set up so that if someone logged in and if they modified the config file, it would send an event to the salt master saying that this file had been modified. And it was like, and then it would apply a high state and push it back down and push the proper configs from Git to that location. So that was to avoid, a sysadmin that maybe had gone in and started fiddling with things. This also could be used maybe for watching for compromises, and maybe there's config files that are changed that they shouldn't be. You can get notified of that and do something for the master. And again, you wouldn't have to necessarily clobber those files and put them back to where they're supposed to be. Maybe you send a notification somewhere to somebody that, hey, some config files are being changed, not through Salt, something's wrong. You had a question?
So, let's say you've already done this with Salt, but you used the watch, and you're using the test equals true, and you're getting your values back, and you've written it in a cron job. What are the benefits of doing it this way opposed to doing it the way that I just described?
So the way to just describe is you're setting up your salt states. That's how you want to manage your systems. So this isn't necessarily for the general actual managing of them. This is more of watching for things that are happening and then taking some action based on those. So they're actually separate things. So you would do both. Does that kind of answer your question there?
Yeah.
This isn't like a replacement for your actual proper sysadmining of your system. This is, let's watch what's flowing, what's happening throughout here.
So the watches only get run when you're applying the states. This is happening like all the time, right?
Yes.
And then the question is, what do you do about rate limiting? So say somebody is changing a directory 100,000 times a second. Do you rate limit that so you don't get spammed on your server?
So here we have an interval that'll check every whatever seconds, but it will actually cache all of those change events. So probably what you would do is there's a feature that just added and developed. It's not in an actual release yet, where you would pause the beacon. So if that was going to be happening, you could pause it, run your commands and things like that, and then restart those beacons.
I was just wondering, I don't want my SaltStack to get denial of service just because somebody does something stupid. That's what I'm saying. Have you built anything in to deal with that?
That would fall back to the main Salt event management type stuff. So it limits the size of all the messages that can be sent. It'll truncate anything that's over. I'm not sure exactly what that is, but yeah, so they deal with that. And a lot of that also gets handled by ZeroQ in the queuing system on there. So we have some users that are doing some really high volume stuff with this, and on a reasonably beefy server for the master, they haven't run into any issues at all with it so far. So
what is reasonably beefy?
Like 8 gigs of RAM, running on an SSD.
6 cores?
No, I think this system had 12 cores on there or something like that.
Yeah, I think
Roughly.
I said 46.
Oh, I thought you said 46. I was like,
46, sorry.
yeah, 4 to 6. Yeah, that's I mean, on my Salt Master that I use, I typically run it with just 512 megabytes on a small micro VM, and I handle hundreds of servers with just that small thing. This master here has a gigabyte of RAM, and like I said, I'll spin up, 800 VMs and connect to it, and it handles it just fine. So it's quite performant. If you get to like LinkedIn size, I think their Salt Master that handles 22,000 servers is I think it's got 16 gigs of RAM. They're not on SSDs, and I don't remember exactly how many cores. It's a decently sized server, but it's not like a huge, massive server that they're running it on. So, yeah. Do you have a question? Yeah. Oh, okay. Okay. All right, so these are some of the things you can.
You have a question?
Oh, sorry, yeah.
So, is it possible to get into a loop where you do something that sets off a beacon, causes your master to fire something off, but then refires the beacon? And
Yeah, you totally could. You could get into a feedback loop. So in the example I gave where if somebody modified a config file in a certain directory, that would actually cause the master to run that state twice, because it would modify the file, it would notice that it would apply a state that would push the correct file down, see that it had been changed again, and then run the state second time, and then nothing would change because salt is idempotent, and then it wouldn't send anymore. So that is something to be aware of. You could get into a bad feedback loop there. So there's other things like you have a load beacon. Do I have? Okay. So you can see here I have a load section. So you can check the load and it'll send an event if it doesn't, if the server is not in that criteria. So if your server gets up to 0.9 or if it's over 1 or something like that, you could have it send an event based on the load of your server, so you can find out that you're not surprised that, like say you have some service degradation, you find out 20 minutes later, well, that server started getting hammered 20 minutes ago. This beacon could tell you immediately that, hey, my 1 minute or 5 minute uptime, my load has exceeded whatever threshold that you want to set there. So you can find out early what's going on. Okay, so I wrote a beacon called it's called a Twilio text message beacon, and I'm going to be changing the account SID and token. So
hurry.
Yeah,
You said that last time.
I did. Or do you have the numbers memorized and you can tell they're the same?
Picture of it.
Okay. And I'm going to set the interval to 5. So every 5 seconds, what this beacon is going to do, the minion is going to reach out to Twilio's REST API and check for text messages. All right. So I'm going to send a text to this my number there. Okay, text went through. We check every 5 seconds. Bam! Got a beacon event saying that, hey, the Boucha server received a Twilio text message. We have the body of the text, who it's from, and then some information from Twilio about that text. So, how can we use that? There's a lot of different ways. One thing that Salt has is a REST API that you can use, reach in, do things with. As part of that REST API, you can actually stream the entire contents or whatever filtered contents you want of that event bus through that REST API. So I'm going to start up our REST API here. I'm going to run it in the foreground here, so if we get any stack traces or anything, you can see it. Okay, so that's up and running. Now I have a let's see here. Okay, so I have a small web page that Salt API itself is serving, and I need to log into this so I can actually authenticate against that API. All right. So what this web page is doing is it's reaching out to Twilio's API. I'm sorry, no, I take that back. It is listening to the stream from the Salt master, and it is displaying the text and any images that are being sent to that API. So let me send another text. Boom. Hi. We can also send an MMS there. I apologize if you're privacy conscious and I just texted a picture of you. So what's happening is that beacon is watching that Twilio text message thing. And when it sees it, it sends an event up to the master. That API is being watched here. And then we're going to post the text and the image there. But for some reason, yes, thank you, whoever that was. So that's the phone number. If you want to text it, you can do it. I'm not sure if we're having some kind of a networking issue, but for some reason we're not getting the images through there. So now obviously this isn't necessarily the most real world type thing you can do with that, but it kind of demos the combination of the beacons. We're watching things that are happening. I could have this upload, any one of those tags that are coming through. So let's say I was watching logins. We could have this web page running, and every time somebody logged into my server, we could post the timestamp and the user that logged in there. You can tie this into any of your existing applications. So if you have an existing web application that you're using for managing your various systems and things like that, it's very easy to reach out to Salt's REST API and make use of that information. It's really incredibly flexible. I spent about 2.5 years, about half my time working on professional services with our enterprise Salt customers. And it was really an awesome experience because I could go out and build almost anything that people wanted using all these really solid building blocks that Salt provides you, but also have the ability to customize things to do whatever you need to do on your infrastructure. So when people would, when the sales teams call me in to talk to on a more technical level with some of our customers or potential customers, it's like 1% of the time where I have to say, oh yeah, we can't do that. Salt either can do what you want to do, or within a day or two of a couple simple Python modules, a couple configurations using all these different tools, you can build out pretty much anything that you need for your system.
So can we take a glimpse at your Python module you wrote for the Twilio, for the beacon?
Yeah, that's a great.
Is this a separate module that's looking at the event stream that's making that web page?
Yep, and we can look at that too real quick. So let's look at the module first. Okay, so we have some boilerplate, some documentation. We're doing some imports. Here we're checking to see if we have the correct Twilio Python modules that you need to have installed. Setting up logging. This virtual name thing is a Salt convention for being able to name your file. It's not required, but it's kind of a convention. This virtual function gets run when the minion starts up, and it checks to see if it meets all the requirements to actually be loaded. So if you don't have the Python module running or installed, then it won't load this module, so you don't get stack traces of things. So that's a good troubleshooting tip. If you're trying to use some Salt module and it's like doesn't exist, what's going on? It's often good to look at the virtual function and see, do I have everything I need? And then there's basically the only required function is beacon. You get the beacon config when it gets called. Every Salt function must have a docstring as well as documentation on how to use it. So here's the documentation. And then this is the entirety of the content. So I have a little bit of logging I'm putting in, making sure we have all of our config items in the config that we need, setting up some variables to put information in, calling out to the Twilio API. And then, if we don't have any texts, we're going to just return that there's nothing. If there are messages, then we're going to pull out information about here from the thing here. Here we're going to loop over any pictures. So you can send multiple pictures in a MMS text message. So we're going to go through and see how many there are and get the list of those. And then we're actually going to delete the message from the server. So this is actually something that I didn't have time to do for this event, but I wanted to add another option to not delete the text from the server. 10 minutes, okay. But right now it's going to delete the text from the server, which is interesting. It deletes the text from the server, but the media files are still hosted by Twilio. So you have to delete those separately. So this is deleting just the text. Since you already have the data, we're not going to request it again from Twilio. And then we're just returning the output. So the data structure that we saw that had the text of the text of the text, or the body of the text, as well as the images, that type of thing, we just kind of compile into this output variable. But that's it. So that's 30 lines of code with some white space. And if I wanted to optimize it for brevity, I could probably make it more complicated. But that's it. That's a beacon to connect to a Twilio account. So you could actually write your own beacon. So if there was some subsystem that you wanted to watch, maybe have it watch. So we actually have a log a beacon, but if you say you had maybe a Django beacon. So if there's something inside of the Django, if some event happened, you wanted to notify your SaltMaster, you could do that. They're very easy to write, and it's really just straightforward Python. So that's pretty much it. Any other questions on that?
What does that look like on your runner on the event log? I'm assuming you have a process running that.
I didn't quite understand your question.
Well, this beacon fires back, and then you have a run. I'm assuming you have a runner that posts the following information to the page, right?
No.
No.
Nope. So what's happening is this beacon is just sending data up the data structure or up the event bus. It doesn't know what's going to happen with it. The web page is a one-page app, kind of just a JavaScript page, and I'm actually logging in. So if you notice on the web page, I logged in right there. That's logging me in to Salt's authentication system so that I can actually access the API. And I'm actually listening on the event bus. And I'm saying anything that has Twilio message in it, send to this web page. It shows up in there, and then I just, with JavaScript, create a new prepend something to the DOM to display the texts as they come in. So there's no reactor actually involved in outputting that to the thing. You could have an event, a reactor that did that if you needed more control over things that went through, or if you needed multiple things to happen. So you could have the reactor, log to a database, send a message, and update the web page, if you needed to. But we're not doing that in this case. So if we look at so here's the web page. I had some help from Seth House on some of this, so I can't claim a lot of this code. But basically, here, this command here, we're listening to /events on the Salt API. So we're listening to events, and then we're going to I'm setting some defaults here, so this is the login stuff. But yeah, we have the default picture. If you want to display if the text does not have an image. And then every time we have a message, this stream.onMessage gets called. We get the data, and then we basically send this small data structure to the web page and update the web page with the JavaScript. So that's basically what I was doing. So you can see here that, I mean, really this web page is tied directly into the /events REST endpoint and processing the events as they come through. So we're not even actually, so there's a whole bunch of APIs, so you can actually say, show me all the packages on every server, and you could get that data and output that in your web page. But this is not doing that. It's just listening on that event bus and doing things with it. All right, so it's 12:20. Are there any other questions before we end and break for lunch? Grab one more back here.
Is there some sort of thing with the reactor? So say we send off a message, reactor grabs it, does its thing, but whatever it's doing has an error. Is there some sort of notification, or how would we find out that what it didn't work?
So the question was, if you have the reactor go and do something, if that thing has an error, how would you know?
Would we need to handle that externally, or is there software?
Yeah, you would need to handle that yourself.
Okay.
So the reactor is designed to be really, really fast. There's a lot of events flowing through. So the reactor actually just matches on the tag, and then it spins up another process, or sends I think it actually sends a worker process to go do that outside the main reactor process, so it doesn't get bogged down by long-running processes or things like that. So inside your reactor SLS files, you would handle that, those error conditions and that type of thing. So I don't really have time today to get deep into that, but
That's fine. That's
yeah. Yeah.
Does that reactor process that you just described, does that run as root?
It runs as whatever your SaltMaster is running as. So if you're running as root on your SaltMaster, then you would, but a lot of people will run SaltMaster as another non-privileged user, so it would run as whatever you set that as. So eventually, I think they're going to actually kind of make that process a little more separate from the master, so you can have some different permissions and various things like that. But right now, it's pretty tied to whatever the master is running as. So, okay. Well, thanks for coming. Really appreciate it. And if you have any questions on IRC and Freenode, #salt is our main point of contact for the community for if you have any questions. It's a really fantastic, newbie-friendly community. We have a mailing list. GitHub.com/SaltStack/salt is where all the magic happens. All Salt development happens right there. So if you have any questions or whatever, please feel free to reach out to us and ask your questions at any time. So thanks for coming. Really appreciate it.